We've been talking about relations or just mapping things. Did we talk about my terrible gift of giving abilities and then mapping it to years? Yeah, that's relations, is any pairing of one thing to another. Years to gifts. You can do people to sports that they play or instruments that they play. You can connect to anything. But a function is one type of relation. And we see how the functions is in a bubble within relations. That means that all functions are what? Relations, yeah. And so a function is a special relation where we're matching one x to one y value, okay? And that doesn't sound very significant, but it's pretty huge. How many of you have jobs where you work? Good. Where do you work? Did you really? At what part of the state fair? Yeah, nice. Red Barn root beer. Where do you work? At the donut shop? Nice. Man, I wish I could get a job like that. Did you say you have a job? Where do you work? At the marina. Okay. Anybody work at a restaurant? Where do you work? Devani's. Oh, perfect. So let's say that Lena works at Devani's and you get a job at Devani's. And what do you do at Devani's? Everything. You run the cashier, you clean tables, you do all that stuff. All right, I'm going to hire Lena to do the same thing, but I'm going to hire her at $12 an hour and you at $10 an hour. How do you like that? You're happy because it's more than what you actually make. But let's say I pay him 10, pay her 12. How are you feeling about that? Well, you're feeling pretty good about that. But you're not feeling very good about that. Why not?
I'm still fine.
You're not helping me here. No. What happens is if you're doing the same job, what should you get? Oh, yeah. Same job, same pay. Doesn't that make sense? So if you were, let's say you were doing some marketing for Devani's, where you're actually getting business from companies and things like that, and you're working at the cashier counter, you could probably see that maybe you would get more pay. Maybe you get 14 and you get 10. But the idea is that if they're different jobs, you're okay with it being different pay, right? But if it's the same job, what should it be? Same pay. So I go up to how many of you have bought soda, or we call it pop here in Minnesota? How many of you have put money into a machine to get a soda or pop in the last month? Really? Okay. So you put your $1.50 in, and you get one pop. What pop would it be? Sprite, yeah. And what would you pick? The Coke? Yeah. So you put $1.50 in, you get one. He puts $1.50 in, he gets three. How are you feeling? You're upset, you're ripped off. You put one amount of money, what should you get? One amount of pop. You should get one job, one pay, $1.50, one pop. You put that one X in, you should get the same Y out. Okay? That's what a function is. And so we have three ways of looking at it. These are different notations. This is more of a European way of showing f of x mapping to y. This is the same as f of x and y. By the way, let's get this going right now. Y and f of x. Anytime you see f of x, what's that the same as? That's the same as y. It's a way of representing y, but when I put an x into the function, I'm going to get a y out, is what it's saying. So f is such that the set of x maps into the set of y, where x is equal to 1 y value. Oh, we got some nice little consequences of that here. So if we have 1, 3, 2, 3, 1, 5, 6, 4, is this a function? Is it a function? 1, put in a 1, I get a 3. But here, I put a 1 in, what do I get? 5. I put $1 in, I get 3 candy bars. Here I put $1 in, I get 5 candy bars. Is this machine working? No. If one person is working at doing dishes and they're getting $3 an hour, and another person is doing the dishes, they get $5 an hour, is it fair? No. Not fair, not a function. So we would say no, not a function. All you have to do is look at the x. If x goes to a different, what if this said 1, 3? Is that a function? Yeah, because the same job, same pay type idea. But as soon as it's something other than 3, it's not a function. Much easier to see on a graph. So let's plot this. 2, 3, 2, 1, 2, 3. There's my 2, 3. 1, 5 is here, and 1, 3 is here. What do you notice? 6, 4 is out here. If we were to connect these, what do you notice about these two and the fact that it's not a function? What do you call this line? Horizontal or vertical? That's vertical, right? The vertical line says that you can have, for a given x, in this case 1, you can have more than 1y. That means not a function. So for a graph, vertical line test, if you have something like this, is that a function? Notice that when I draw a vertical line, every x has 1y, every x has 1y, every x has 1y. That's a function. But as soon as I do something like this, Sonic the Hedgehog style, is this a function? Here it is. Here it is. It's a function here. Every x has 1y, every x has 1y. But what happens here? I can go here or I can do here. Do you see how that function has to have 1y and it doesn't? This is a problem. We can't graph this in our calculator yet. But in the spring, we're going to teach you parametrics, and you're going to be able to use the calculator to draw weird spirals. We'll do spirographs. We'll do all kinds of cool things. We'll be able to make a curve like this into 2 functions that make up 1, and we'll be able to do it. But right now, this is not a function. The last thing is equations. This is the one students have the most trouble with. Everybody listen up. Whatever you do, make sure you listen to this next thing. If you come away with one thing today, this is what I want you to come away with, is that if you have x minus y squared equal to 4, solve for y squared, x minus 4 equals y squared. Now, for this to be a function, what has to happen is that y, every time I put in an x, I have to put in 1y. What if x is equal to 5? What will y be? Remember, every x has to have 1y. If x is 5, what will y be? 1, correct. Is that the only thing that'll work for 5? What else will work? 5 minus 4, what else could be squared to give you 1? Negative 1. So what do you notice? Every x have 1y? Not in this case. So this is not a function because it has what I like to say, 2 rules. It's not a function because it has 2 rules. There's 2 answers for this. One is y is equal to plus the square root of x minus 4, and the other is minus square root of x minus 4. 2 rules, not a function. All right, and I think that's pretty much it. Double check. Oh, last thing. So we can use a function to evaluate things that are kind of weird. Like, let's say I put in a 4 into f of x equal to 3 minus x squared. When I put a 4 in for x, what do you get? 3 minus 16 is what? Negative 13. You got it. 13 is good. Now this one is interesting. What's x? Turn to your neighbor, see if you can answer that. What f of x equals 2? What's equal to 2? Y. Yeah, remember f of x is the same as y. So what you have to do is say 2 is equal to 3 minus x squared. And so I'm going to move the x squared here, and then I'm going to subtract 2. 3 minus 2. So there's your 1 again. What's x equal to? Careful. 1 is correct. Anything else? Negative 1 and 1. You got it. So x is going to have two answers to get 2. You're going to be able to put in a 1, and you're going to be able to put a negative 1. Let's check. What is 3 minus 1 squared? 2. What's 3 minus negative 1 squared? Also 2. So it works out. Here's where it gets interesting. F of c. Now what am I going to put in instead of 4? What am I going to put in for x? C, right? There's my x value. So this will just be f of c equals 3 minus c squared. I'm done. I don't know what c is. What is f of c plus 1? What do you put in for x this time? What do you put in? C plus 1. And you could expand it and so on, but that's essentially what you're going to do. So all of these, I'm putting in something different for x. This guy, to throw you off the scent, this is what y is equal to. So you got to be careful. You set the f of x equal to 2. Now with this one, now that I've told you this, f of x plus h minus f of x, first thing we're going to do is wherever you see an x, what are we going to put in its place? According to this part, what are we going to do? X plus h. Yep. Please write that down. And then minus f of x, which is 3 minus, what do we put in for x this time? X. Kind of boring. Okay, so this is going to be 3 minus x plus 1 times x plus 1. I got to go back here. Foil that out, you'll get x squared. 1x plus 1x is 2x. And then this is going to be plus 1. Minus 3. What's minus a negative? Don't forget to distribute. Plus. Yep. So then this is going to be 3 minus x squared. Should I go plus or minus 2x here? Minus 2x. Plus or minus 1? Minus 1. Someone's going to make that mistake on the next test, but don't let it be you. Don't forget to distribute here. Minus 3 plus x squared. So what happens to the x squareds? What happens to these two? Cancel out. What happens to 3 and negative 3? Cancel out. And so you're going to get negative 2x minus 1. Now, that answer looked very significant to you? Not really. But guess what? You just did calculus. One of the steps to doing differential calculus. We'll do more with that later, but that is a problem you're going to see in the future. Yes, it's Monday morning. This should be an H, excuse me. So it'll be H squared 2x times H. I am so sorry, I screwed that up. Let's try this again. So you're going to have 3 minus x squared minus 2xh minus h squared minus 3 plus x squared. We're still going to lose the 3's and the x squared. So you're going to get negative 2xh minus h squared. Thank you for catching that. My mistake. And we'll work with those. I know we're going to work with those in the next couple days, so you get good at that. So for the problems, you're going to determine whether these are functions or not by drawing a picture or just looking for repeated x, y coordinates. And then here's some drawings that you're going to do. And oh, by the way, domain and range. Let's do this one real quick. Find the domain and range of this. Is this a function, this guy number 15? Does it pass the vertical line test? Yes. So we would say, yes, it's a function. The domain is going to be all the x's that you can have. Are there any x's? It's going to be everything, right? So you just go R with a line next to it. That's not independent Republican. What it is it's, or IR, it's an R with a little bar next to it. That's all of the x's can go here. What about the range or the y's? These are the x's, here are the y's. What y's are we going to have? Any y's? What's y got to be greater than or equal to? 1. So that's the domain, are all the x's. This goes forever this way, forever that way. But the y's start at 1 and go up. And you'll be able to find the domain and ranges for those. And then determine whether this is a function, yes or no. And there's a couple of problems for you to try, and that's it. And so that's your assignment for tomorrow. So how much time do we have? Okay, good.